Good day and welcome to another edition of Introduction to Statistical Analysis and Machine Learning with Python. Today we'll be treating data analysis with Python Pandas. So basically in the last class we treated NumPy. I know it's been a while, so sorry I've been a bit busy. So today we'll continue with our series. So today we'll be treating Pandas majorly, and what we'll be treating is Introduction to Pandas, working with series, working with DataFrame, working with missing data, group by. If we have time, we'll enter merge and join, but I'm not sure we'll be able to exhaust everything we have in stock today. But if we don't finish today, we'll finish in the next tutorial. So let's get to it. So a series is very similar to NumPy array. In fact, it's built on top of NumPy array object. What differentiates the NumPy array from series is that series can have axis label, meaning it can be indexed by label instead of just a number location. It also doesn't need to hold numeric data. It can hold any arbitrary Python object. So basically what this is telling you is NumPy holds just numbers and it can only be indexed by numbers, but series can be indexed by other things, can be indexed by string and the likes. Then you can save any arbitrary data in a pandas series. So basically the first thing we need to do is what? Import NumPy then pandas, since we built pandas on NumPy. So that's why we are importing NumPy. So getting to it, so we created 1, 2, 3, 4. We created 3 lists. Okay, 2 lists, 1 NumPy array, 1 dictionary. So basically that's what we created here. So label is a list, my list is a list, array ARR is NumPy array. If you don't understand what array is, check the last tutorial. Then D is a dictionary. So you can see key value pair, key value pair, key value pair. So let's run that. So pandas series. So we want to make pandas series from data equals my list. Where's my list? This is my list. So running this now, you can see automatically it gives it an index which is almost similar to the index we have in NumPy array. But here, instead of we just having the normal series, we are creating our own index with the label. You know, normally NumPy array has its label to be 0, 1, 2, 3, that is numbers, integers majorly. So here we are setting our own labels to be A, B, C. So if we run this, you can see A, B, C instead of 0, 1, 2, and it's just a quick tweak in our code by adding comma index equals labels to what we have. So another thing is we can form our pandas series with just giving it the data and the label, but in this particular order, instead of we just having to put the data equals this, index equals this. So we can do the same thing with this and still give us the same thing. So another thing we can do with series is we can use the NumPy array to form a series. So that's what we did here. You can see it's giving us the 1, 2, 3. Then we can give it the same label again. So you can see that. Then we can form a series with the dictionary. So the key will be the index and the value will be the value here. So that's exactly what happened here. So that's on that. So data in series. So pandas series can hold a variety of data types. So this series equal, data equals label, so you can see. Then another thing is series sum, print, length. So we can have even function, although unlikely that we use this. It's unlikely we'll use this, but you can add functions in NumPy, in a pandas series. You can see it's put everything in there. So now, using an index, the key is using a series the key to using a series is understanding its index. Pandas makes use of this index name or numbers by allowing for fast lookup of information. Works like a hash table or dictionary. So the reason why pandas is allowing you to add index is basically for you to be able to easily look up information from your data table. So for example, here is another data type here. We see our index US, Germany, USSR, Japan. So if we call our series 1, you can see our index is USA, Germany, USSR, Japan, and our numbers is 1, 2, 3, 4. So basically, and that series 2 has another set of numbers. That's USA, Germany, Italy, Japan. You can see there is no USSR here, and at the same time there is no Italy here. So if we call, you know the way we call, what's it called? Use index to call values in a list, or use key to call value in a dictionary, or use index to call value in a numpy array. We can use our index here to call our values in a numpy array. So you can see series 1 plus series 2 gives us, Italy is not a number because Italy is not common to the two of them. Likewise, USSR2 will give us not a number because it's not common to the two of them. So that's on that. So DataFrame are the workhorse of Pandas and are directly inspired by the R programming language. We can think of DataFrame as a bunch of series objects put together to share the same index. Let's use let's use Pandas to explore this topic. So basically, DataFrame is more like what we use in R. But mind you, if in case you want to learn R programming too, or you want to use it for statistical analysis and machine learning, there is a simultaneous series running with this on this channel where you can learn R programming. So you can just check that series out to do that. So here we just want to import our random number. So rand n, then we are giving it a random seed 101. The reason why I'm giving it a random seed is so that the number I generate and the number you generate will be the same. You can read more, just Google random seed. Just Google random seed, yes, to understand what I mean by this. So that, for example, if you use 10 random seeds to generate a set of numbers together, we'll get exactly the same random set of numbers. So just check it on a search engine, either Bing or Google, whichever one. So let's go on. So we want to create a data frame, random number 5, 4, index A, B, C, D, E, then split colon equals W, X, Y, Z. So if I run this, you understand what I mean now. You can see random number 5, 4, that's 5 by 4 matrix. That's 1, 2, 3, 4, 5. 5 on the x-axis, 4 on the y-axis. 1, 2, 3, 4. That's that. Then the index A, B, C, D, E. That's A, B, C, D, E. Then we say the columns is W, X, Y, Z. W, X, Y, Z. Majorly for this series, this is the major data type we'll be using. Data frames. That's the major data types we use, and it's just basically a merging together of a set of series that share the same index. Mind you, we might not really necessarily use a lot of these indexes when we are doing our work. We allow Python to automatically give us the normal 1, 0, 1, 2, 3 for our indexing. But if you are working with stock data and the likes, you can always call on your indexing. So selection and indexing. So let's learn the various methods to grab data from a data frame. So let's say we want to grab W, that's W, to grab the whole of this colon. So if we run that, you can see grab the whole of that colon. You can see we use double square bracket here. We want to grab 2 colons. You can see that's why we use double square bracket. Or you can just use dots to call a colon. So df.w, you can see it's giving us exactly the same thing as this of this square bracket. Then you have to quote again. You can just call it like this. But mind you, if your colon name has space in between it, then it's going to be a problem. Though this is not recommended, as I said, if it has space in between it, it's not going to work. So you can get your data type. If you call data type for a row, a colon, it will give you it's a series. But if you call a data type for the whole thing, you can see the data frame. So it's just a combination of different series to form a data frame. So that's on that. So you can form a new row. For example, when you are doing your feature engineering, you can form a new data type, a new data column in your data by just adding 2 colons, multiplying 2 colons, or applying some mathematical operations on a colon or multiple columns. So that's what we are doing here majorly. So you can see new is already added, which is W plus Y. So it's just majorly this plus this. If you add this and this together, it will give you this. You add this and this together, it will give you this. You add this and this together, it will give you this. So that's that. So okay, let's go on. Then df.drop, that is we want to drop the new axis we added. But mind you, we are calling axis 1 because if you call drop directly, it will just go to axis 0, and axis 0 is here. Axis 0 is our x-axis, axis 1 is our y-axis. So if you want to drop anything on the y-axis, you have to add axis equals 1, because by default it picks axis equals 0. So if we run this, you can see what's giving us. So we now call this, you can see it's still giving us this. But for us to actually have it drop axis new, you have to put in place equals true. Or another thing I do is, probably I don't want to remove the data, the colon completely, so I give it a new name. I can say maybe if equals df dot drop new axis 1. So that's that. So, or you can use in place if you want to maintain your data name here. So you can see the new is gone because we put in place equals to, that is, we are replacing the data with the new data type that we are forming. Can also drop row. You can see I said axis 0, or you can use dot loc a, that is, you are using location to locate a. You can see that. So if you run that, you can see it's calling you location a. iloc 2, that is, you are using index location 2, so to locate the second row. Yeah, second row. If you check that second row, iloc 2, that's 0, 1, 2. So here will be what you are seeing here now. So that's that. So another thing is set subset of row and column, that is just location, for x comma y, that's more like, how do I put it, b comma y. So that's to give you this. So that's basically what we did here. So you can set subset of multiple rows and columns. So just give you what is on row A and B and column W and Y, and that's what it's giving us here. Then we have conditional selection. I don't want this tutorial to be long, so we'll stop here. I will continue in the next tutorial. Thank you for watching this tutorial, and don't forget to like this video, subscribe, and click the notification bell. Thank you, and God bless.